So why don't we fall off roller coasters when they do that loop-de-loop? Let's see what maths they do. So in a roller coaster, we can see when you go on the loop-de-loop, you can see that the tires are in contact with the track. So that we have a reaction force pushing through that tires, through that base of the roller coaster, and it's going in the downward direction towards the middle, right? But we also have gravity, that force, that weight pulling you down. We can call that reaction force a support force, and that weight pulling you down is just obviously due to gravity, and we know that weight is equal to mass times by gravity. Same way if we're standing on flat ground, you have gravity pulling you down, but this time that reaction force from the ground goes through your feet upwards, whereas here, through the tires downwards, brings it in the same direction. So we have these two forces, that support force and the weight, pulling you down. That's the resultant force. And that resultant force in circular motion is called a centripetal force, and we can write that as mv squared over r. The mass times the speed squared over the radius of that roller coaster. If the roller coaster's got a height of 50 meters, we could say then the radius of that loop-to-loop would be our 25 meters. So I know that this roller coaster will stay on the track as long as there always is that support force, that force through the base. So I don't want that support force ever to go to zero, because if it did, the roller coaster will be no longer in contact with the track. So what I can see is that the support force is equal to mv squared over r minus the weight, or minus mg. And we don't want that support force to ever go to zero. So if we don't want this number to go to zero, we can see that mass times gravity must always be less than mv squared over r. We can cancel mass from both sides to see what that minimum speed is. We can see that the speed must always be greater than the square root of g times r. So again, the speed must always be greater than g times r. So g on Earth is 9.81, and if we plug in our numbers with a radius of 25, we can see what that minimum speed is. So if we do 9.81 multiplied by 25, and then we take the square root of that answer, we can see that minimum speed comes out at 15.66. So 15.66 is that minimum speed the roller coasters have to go at. If they go any lower than that speed, that's when the roller coaster would fall off and you come off the track. So this is the maths they do to make sure that you're safe.